All right, almost time to start, so we'll get started soon. It's a much bigger crowd than I thought they'd be. I was expecting no one to be interested in this session and everyone to be in line for Surface Pros or something like that, or lunch. So my name is Alistair Spears. I'm a Senior Operations PM in the Microsoft Office division. So we're responsible for such products as Office and Excel and PowerPoint and Word, as well as the server products like Exchange, SharePoint, Link, now Yammer, Project, Visio, and of course the cloud service Office 365, which is where I spend most of my time. So the idea behind this session was I really wanted to take you through a little bit more about the inner workings of Office 365. I think a lot of us approach cloud services like this black box, and we really don't look inside and under the covers. And I think for IT professionals, even if you don't need to be in the black box every day, for kind of working on what's going on in those servers and those sorts of things, you still need to understand how it works. I mean, that's what separates us as professionals from users or as just consumers or practitioners of the technology rather than actually true IT professionals. So I hope this is very insightful for you. I hope it helps you make sense of Office 365 when you see weird things happen. I hope that you can imagine what's actually going on in the background and how many people are running around frantically trying to make sure that you have a great experience as well. I guess from my accent, you can probably tell that I'm not from around here. I'm from kind of the deep, deep south down in Australia. I moved to Seattle about 3 years ago. Slowly getting used to the cold weather. It's a big change from Australia. So I love being in New Orleans. It reminds me of home. Nice and humid weather as well. So what we're going to cover today, a couple of things. Really I want to spend most of our time focusing on how we meet some of those kind of traditional IT challenges inside the Office 365 team. But I also do want to talk a little bit about cloud in general, how we do service continuity, how we do service upgrades, and how we kind of evolve the Office 365 service as we go through as well. A question I get a lot of the time is, what about me? What about my job? What about IT professionals in this Office 365 service? Does the cloud mean I'm out of a job? And I think there can't be anything further from the truth. So I want to take you through some of the areas that we see the IT roles evolve as customers move to Office 365 as well. And I'll talk a little bit at the end about the easiest way to get onto the Office 365 service itself. So a show of hands, who's using Office 365 today? Fantastic, great. Who's thinking about it? Not there yet? Great, yeah. Who's never heard of Office 365 before? No, a couple of people. Yeah, what's Office? Yeah. Let's start from the top. Yeah. It's funny, about 2 years ago, that was a little loud. About 2 years ago, we were doing some research and working out, how much IT pros thought about at Office 365. And we actually found that, a product name that we just made up had more awareness than Office 365. So it's come a long way in such a short amount of time. And I still hear a lot of people that don't quite understand what Office 365 is. They know it's something to do with Office, it's something from Microsoft, it's something productivity, it's something cloud, but they don't really know what it is. So this is kind of my mental model. It's not much of a marketing slide or a sales slide, but this is kind of how, inside of my brain, I think about what Office 365 is. Firstly, it's a set of productivity services. Most people understand this. It's been this for quite a long time, before it was even called Office 365. Back in the BPOS days, it was a Microsoft-hosted version of Exchange, of SharePoint, of Link, and other kind of server roles and those sorts of things. But also, Office 365 is also the client applications. It includes the Office client. It includes the Project client, Project Online, Project Server as well in there. Includes Visio, includes mobile access apps and those sorts of things. And these are all things that, by and large, you can build and manage yourself if you want to. You probably have been for quite some time. What really starts to set Office 365 apart, other than the architecture, which we'll take you through, and other than the fact that Microsoft is running it, is some of the kind of extra bits that are bolted on. One of the things I like to think about is the user experiences. When you're building an on-premises Exchange environment, generally you can't rely on SharePoint being there, or you can't rely on Link being there, so you try and keep everything fairly isolated. Whereas with Office 365, because we turn on all that functionality at once, we can start to do some consolidated user experiences. We can combine the sign-up experience or the administration experience or landing pages for particular users in a very simple manner as well. And also, it's the platform services, that are shared amongst the Office 365 services as well. That's, as simple and straightforward as the commerce and billing systems, the identity platform, the authentication mechanisms, the automated systems around service management, and also things like the network, the hardware, the infrastructure, and all those sorts of things. So Office 365 is kind of all of these things. Maybe what you see is just the red or just the red and purple. But I think of this as all Office 365. Rather than one service, it's really a set of federated services that are all bringing you that consistent Office experience. We have a session straight after this, actually, OUC B202, called Choosing the Right Cloud Service. So if you are brand new to Office 365, you're kind of confused by the different plans that are available, whether I should be a small business or a mid-market or an academic or an enterprise type of Office 365 customer, you can look at that session. We'll take you through what all of those experiences look like and how they differ. So let's start with the cloud. And for many people, I often think that their vision of what kind of cloud computing looks like is kind of something like this. So yeah, let's move to the cloud. It's full of sunshine and rainbows and unicorns, and it'll be easy, and nothing will ever break, and I'll always be up to date. And it's fantastic. Like, how soon can we get there? And that's maybe a little bit oversold. How do you even justify that, right? Even at its most basic, yes, perhaps a cloud service can give you more uptime, but I'm sure we've all been victims of when cloud services have been down. It's great that cloud services may add features much faster than we can possibly do on our own when we're on premises. But how many of you have been kind of victims of features that you've liked or features that you've loved being taken out of a cloud service as well? And so, there's a lot of hype about cloud services, and I think, I really don't like the word cloud. I much prefer to think of the term service, and that's really what we're offering here. It's not a product, it's not a cloud, it's a service. And a service is something you do. It's not something you make. It's not something that we give to you. It's just something that we continue to do. And that's why I really focus on service as well. I mean, not to be down on cloud or anything like that. We're all cloud customers, and I think, what we've seen in all aspects of technology, that cloud has made some big breakthroughs, like online gaming, social networking, storage, music, video, the entire kind of entertainment industries that have been transformed by cloud computing. And so we've got a lot of value out of cloud. But also cloud services have benefited a lot from us. And I think that's one of the interesting things that we think about a lot when we're building an enterprise cloud service rather than just kind of a consumer cloud service, is some of those differences there. And they can be very subtle. I mean, for consumer-grade services, oftentimes, the real goal is a funding mechanism that may not be the user itself. And sometimes, as a user, you're not actually the customer. The customer is the advertiser, or the customer is some other tool. You're actually the product. You're the commodity that is sold to those advertisers for your eyeballs, or whether it's a system that is all of a sudden asking you weird profile questions to fill in your profile more and more. The idea is so they can get more reach, get more relevance, and start to really profile you so they can target better ads, perhaps more valuable ads to your eyeballs and those sorts of things as well. In the case of Office 365, and something that we are really focused on with Office 365 is that it's about user productivity. That is what's key in Office 365. I think it's very hard to kind of reconcile productivity with advertising. Productivity is all about helping you focus, helping you do your job better and better. Advertising is all about distracting you to go and buy something else. So I think it's really hard where you have that kind of diametrically opposed kind of ideas that you're trying to work on. And so we focus on user productivity, a very simple model that we make you better, you pay us money, and everyone's happy. And then it's just a cost versus value conversation. Are we making you enough better that you'll pay us money? If not, you're not going to buy the service. If we do, then you'll buy the service and you'll get a lot out of it as well. That's about all I wanted to say about that. So, Office 365, what do we do when we wake up in the morning in the Microsoft Office division? This is really kind of our design goals, or our vision, if you like, of how we see computing evolving and what we really like to focus on as well. We love building tools to help you do your best work, and that's really what the Office team's all about, all the different products that we make. It's all about building great tools across all the devices that you may want to use, whether it's PCs, whether it's laptops, whether it's tablets, whether it's phones, whether it's web, whether it's 82-inch multi-touch screens or anything like that. Our focus is really on how we can evolve that productivity story as well. But then more and more, it's about building these enterprise-grade cloud services to power those sorts of experiences as well. It started back in 1993 when we first introduced Exchange. It was the back-end component to make Office a richer experience, and over time we've added more and more of those back-end components, and over time those components have grown out of just a server into a complete cloud service as well. Then the sorts of things, these are kind of the trends we see are really important as well, like being a very dynamic workplace, helping you work the way that you need to work in 2013. We're not working the way that we did 10 years ago or 20 years ago, so the tools that we use need to adapt and help meet those needs. We have more and more information that we're having to deal with every day. And I think for those that were in the keynote this morning, you may have seen the GeoFlow demonstration, which is a way of how we're using Bing as a cloud service to overlay it with data from Excel or data from SQL Server or even SQL Azure into an Excel dashboard overlaid with a map to help you make sense of those really complex data sets as well. Merging like what you do at home, what you do at work, so you can get a great work-life balance. Natural expression, things like inking, touch, voice recognition, and those sorts of things are other big things that we invest in. And then also, helping you be a responsible organization. And this is, for us IT pros, this is generally kind of our job is to help police the use of this technology, help make sure that we're regulatory compliant in the organizations that we work with, help making sure that corporate policies are being upheld and those sorts of things as well. So that's kind of our view of productivity. So when we think about meeting the enterprise challenge with Office 365, really I like to think of it, these are the two big challenges that we're going to talk about. And there are other challenges. No doubt you all have many challenges in your day job. We can spare a thought for all those people that are back in the office working on those challenges right now. It's good to be in New Orleans. And maybe this is a pretty big audience, so chances are someone's going to run out of the room at some stage with some urgent call, some system down, and those sorts of things. But the IT challenges that we'll talk about today are really building great technology and then managing great technology. There's a whole discipline around making sure that great technology is what the business wants. That's your job. So I'll talk about Office 365 first, this sort of thing. Let's focus first on how we build this sort of infrastructure and how we build it to be scalable, reliable, and efficient. So, scalability. When we think about Office 365, we do think global scale. Our stated direction is a continuous cloud service for every business and every person on the planet. That's kind of the scale that we're trying to architect our solutions to meet. Billions of mailboxes, billions of documents being created, millions of tenants, and those sorts of things all in this infrastructure. So, for Office 365, we leverage our Microsoft global data centers, and don't get too hung up on where these data centers are or anything like that. We have much more than this. We generally say we have more than 10, less than 100 data centers spread out around the world. We don't give out the exact numbers because they constantly change. And for a data center for us, when we mention a data center, we're talking about a facility that has more than about 60 to 100,000 physical servers in it. That's a data center for us. Everything else is just either a really big server room or under someone's desk or something like that. So when you hear Microsoft say data center, that's what we're talking about when we're talking about these data centers. Of course, that's not the extent of the network that you need to run something like this. And so we essentially have these edge nodes or sort of mini data centers spread out around the world as well. And these act as kind of our edge of our fiber network. They interface directly with your carrier or someone like that so that we can get really fast experiences. And we cache down a lot of the sorts of experiences that you're dealing with, whether it's the JavaScript code that's running in OA, whether it's the Office client install code that you're installing off the off the service or anything like that. That's often moved down to those edge nodes at the edge of our data center network. And of course, the network itself, a massive fiber network. People often use the term dark fiber. This is being used, so I guess it's not so much dark fiber as light fiber. But we got lucky in being around for over 30 years now at Microsoft, is that we've been through a few technology revolutions before. The dot-com boom and bust, we were still standing. Fiber got really, really cheap, and we bought a lot of really cheap fiber back then. And we thank our lucky stars that we bought our fiber when we did, because if you try to buy fiber right now, it gets more and more expensive, and you end up having to lay your own pipe in a lot of these places as well. So let's dive in. Let's look at a particular area. We generally divide up Office 365 into geographic areas. We do this for a number of reasons. One, it limits the failure domain. And two, and perhaps more important, that it keeps all of the data and all of your data in the one geographic area, in the one legal framework. If we were kind of spreading and sharding your data all around the world, you'd get some pretty interesting challenges when it started to come by regulatory compliance. There'd be all sorts of different government agencies, regulatory bodies that may have responsibility or ownership of that data and laws that you need to comply with. So by breaking these data centers into networks, in the case of the US, you're in the US, North America, you're in that same regional framework, so you know exactly which laws apply to your systems and which laws don't. And then, of course, the edge nodes we talked about before, spread out around the country as well, integrated. They're essentially kind of the fastest route to the back end, back into the data center, back into that fiber network as well. And then, of course, those edge nodes peer with metro solutions, your carrier, your other telco companies, and those sorts of things. And it's those peering relationships that essentially mean that data will travel from that metro solutions network, from that telco, direct to the edge node, into the data center, and it'll be a very efficient path for that data. So only a few hops before you get into our edge node, and then you're on the Microsoft highway, if you like, back into the data center. And of course, then there's always the last mile. That's how it gets to you, to your office, your house, your mobile phone, all those sorts of things as well. And we don't manage that necessarily. You have your telcos and those sorts of things that provide you those solutions. But what we can do, and what's I think really great about the Office team and Office 365, is that we don't just rely on that web app experience. We can also rely on the Link client or the Office client or Outlook or something like that. And so we can do things a lot smarter because we know what's in the back end and we know what's in the front end. So that means that we can start taking advantage of things like peer-to-peer traffic. When you start a Link call, you can do a peer-to-peer video call and those sorts of things. It means that that video traffic doesn't have to jump all those hops back to the data center and all those hops back down the other side out to the other user. You can set up a peer-to-peer connection there as well. So it's not just kind of a really big client-server model. There's a lot more to it. There's also elements of peer-to-peer in here between the users and the final endpoint, but also peer-to-peer between the data centers, the edge nodes, and those sorts of things to really optimize that traffic as much as possible. So that's kind of the network, the high-level view. When we jump down like really deep now into the Exchange topology as an example, our general approach is to try and partition as small as possible these sorts of environments. When you just add and you scale up and you add more and more sort of infrastructure here, you still have relatively few points of failure. And that's just not great when we're running a sort of system like this. So we have multiple partitions, multiple sort of Exchange farms, and Exchange scalability units that we add in here as well. Tens of thousands of servers are running something like Exchange Online in the back end here. Process about 1 billion messages every day that flow through Exchange Online. So it's a fairly large system, perhaps one of the largest systems in the world. I think it's definitely one of the largest Active Directory implementations in the world just to power this Exchange Online experience as well. When you start to do that, when you start to scale out rather than scaling up, you come into a couple of problems. One of the problems that you often encounter is what we like to think of as configuration drift. That's when you're making a change. Perhaps you patch one particular server, or you update, you change a setting here and those sorts of things, but you haven't changed the setting on every single machine. So all of a sudden, this machine is a little bit different to that machine. There are a few anomalies you'll find in this system that you won't find in this system. And after a while, when you have thousands upon thousands of servers, you can get into some really, really big messes. So we solve that by automation. We spend a lot of time doing data center automation to make sure that rather than making an update to a particular machine or a particular configuration, we do it in code. We do that update in code, and that code replicates to every single server in the farm as well. So that's how we kind of address some of those configuration shift challenges that you'll see in big systems. And maybe you're even dealing with a smaller system on premises as well. SharePoint, very similar model. Essentially those scale units we think of, we use the term stamp. And a stamp is the term, is really that kind of self-contained partition of SharePoint or Exchange or something like that. In the case of SharePoint, it's generally to the size, it's not an exact science, but it's about 150,000 to 200,000 user capacity is kind of our unit of scalability. So we don't add more capacity for 500 users or 1,000 users or a single user. We're adding capacity in kind of 200,000 user units. And that's really the scope that we look at the service. Like, is this up or down? We don't look at a particular user or a particular farm. We try and get above all that so we can just see how the service is functioning. So if you're familiar with SharePoint, this is probably pretty basic here, where you have your directory, you have your SQL systems, you have your kind of content farms, your web front ends, your certificate authority, your app server, your timer jobs, all that sort of thing. Then you have some federated services in there as well. Federated query engine, federated Active Directory, or your identity platform, your certificate authority, and those sorts of things. And that kind of self-contained unit makes up the stamp itself. And then those stamps, we just stamp out. And multiple stamps make up essentially a SharePoint network. And in that network, it's made up of other things like the AD synchronization, the SCOM engines, the domain name services, the backup protocols, SMTP interface, the provisioning systems, the admin systems, and those sorts of things as well. So all of a sudden, that is your SharePoint network, and then multiple SharePoint networks run inside of the same data center. Network load balancing on the front of that, and then we push that out to a disaster recovery data center as well. So essentially, that same sort of infrastructure replicated in another location, a separate geographic location, to keep that system up and running as well. So it starts, it's really just SharePoint under the covers. Just like Exchange is really just Exchange under the covers. It's really the architecture that we build it in is what really changes how this looks from perhaps your traditional on-premises deployment. And of course, just like in Exchange, there's a whole bunch of automation that we do on front of this so that we don't get that configuration drift. We don't get servers looking different in this experience. And so we call that in the SharePoint parlance the grid manager. This series of networks and stamps we call the grid, and that controls things like the global directory, the tenant administration, the integration of the commerce system, the domain name servers, the org ID and the authentication, the incident management systems, and all that other stuff that makes up the service itself. So that's really the system that can give us that sort of scale. We can handle up to 25 terabytes per tenant in SharePoint Online. We allocate 7.5 gig per user per tenant in SharePoint Online as well. We have 25 gig mailboxes in Exchange Online. We can handle unlimited mail archiving in Exchange Online as well. Hundreds of millions of mailbox, billions of messages a day. We have a cloud app model that you can start to even customize this environment to run your own sort of systems. But at its core, it is a fairly familiar model. It's a model you can understand if you're an Exchange professional or a SharePoint professional, because it is still that same stuff. It's not a black box at all. So let's talk about reliability then. When we get to that sort of scale, reliability is kind of hard to get sometimes as well. The first thing we think of is service continuity by design. Like, that is the high order bit when you're looking at a system like this. How do you essentially add more nines to the environment, making it more and more reliable? There's a number of things that we do in this architecture to make that happen. First, we can add some redundancy, physical redundancy, data redundancy, functional redundancy in that sort of environment as well. We also add resiliency, which is really about active load balancing, so we can move load between those sorts of environments to make sure that we're not that we're load balancing appropriately, that we can recover easily across those failure domains, those partitions or those stamps, so that if one particular environment fails, you can fail over completely, or you can fail over even within the stamp or within the partition itself without much effort. It's also about distributing the workloads. All of these workload components are resilient. This is a federated set of services. We're trying not to have failures that can affect, for instance, Exchange and SharePoint at the same time, that sort of thing. We want to isolate as much as possible these different services so they can continue to operate at a very high SLA. This isn't a fully automated system. We have a lot of automated agents. We have a lot of things that the system can self-repair and self-heal when it encounters certain problems, even to the point of restarting a machine, reloading a machine, re-imaging a machine, and those sorts of things can all be done in an automated fashion. But there's still a human in the loop. We think this is really important that our on-call engineers, which are part of the Office product group, part of the Exchange development team, part of the SharePoint development team, the Link development team, look at and manage this service to make sure that it's operating as much as possible, and get woken up in the middle of the night when things go wrong. I think that's one of the things that has made our software so much better recently, is making the engineers run the service at the same time. It's one thing to build an on-premises mail server and kick it over the fence and say, hey guys, your problem. But when we're running the services, we feel the pain directly as well. We don't have to wait for the support call to ring or anything like that. Inspectability and predictability. How do we make sure that we log everything? We generate terabytes and terabytes, I think about 40 terabytes every day of just log files through this environment. So that huge kind of big data problem of analyzing all that, inspecting all that to make sure that nothing is going wrong, and if things are going wrong, or even if things are trending towards badness, we can start to look at that through all this log information that we gather. And finally, you're trying to avoid complexity and then gracefully fail machines is something else we look at as well. We start to design these systems as if they're going to break. Systems will fail. Eventually, these systems will fail. So we try to look at how can we take out as much of the complexity as possible. How can we build with failure in mind? Because we know that sooner or later, these servers will fail, but we don't want the experience to fail. And that's kind of the thing that drives us in this sort of reliability mode as well. We have another session coming up, OUC B216 on Office 365 service communications, where we'll talk a lot more about how we do service continuity, reliability, and service communications as well. So I'd encourage you to attend that, especially if you're an Office 365 customer or you want to become one. That's important. So again, this idea, Office 365, loosely coupled workloads. We're separating out the functionality here. We're separating out Exchange to SharePoint to Link. We're separating out the identity management platform and those sorts of things. And you can think of it as kind of loose contracts between all these services. So just like in Office 365, you might run a tool like DirSync to synchronize your Active Directory up into Office 365. Really what you're doing is you're synchronizing your directory into a service called Windows Azure Active Directory. Windows Azure Active Directory synchronizes that directory out to Exchange, out to SharePoint, out to Link, and those sorts of things. So if, for some reason, one of those major services goes down, Exchange can still operate with its own Active Directory, its own synchronized copy of that same information as it goes forward as well. So that's kind of just a way we isolate some of that failure to happen through the service as well. System monitoring. Who's monitored an on-premises Exchange server before? Anyone use the SCOM management pack and those sorts of things? Yeah. So I think there's about 1,700 alerts that can be possibly triggered by the Exchange management pack, which is a lot of alerts. And the reason that there's a lot of alerts is that when we work closely to build those sorts of systems, it's those sorts of alerts that the engineers want to have, right? They know that code better than anyone else, so having more alerts makes it easy for them to debug what's really going on in the system. You know, when we started looking at Office 365 and really scaling this up using that sort of technology, we couldn't handle 1,700 alerts. That's way too many. It's, you know, how do you separate the signal from the noise in that sort of environment? So we actually identified only 200 of those alerts that we really cared about. 200 of those alerts were telling us that a customer experience had been impacted or a user experience had been impacting. Those other 1,500 alerts are kind of important to know. We can pick them up from the log files and those sorts of things out of the track as well. So it was kind of a mind shift for us to stop thinking about triggering alerts and raising alerts, you know, when we wanted to find some sort of kind of debug code, if you like, and start thinking of it from the user experience itself. How do we do essentially outside-in monitoring? How do we look at what is that experience? And so we've built, you know, big systems now to really scan and target, in the case of Exchange, every 5 minutes, every 5 minutes a database will be hit, you know, from externally to make sure that it's still up and running. You know, there'll be 4 different database copies of a particular mailbox at any given time throughout the Exchange Online system. So that means that, you know, every minute we're checking to make sure that that mailbox is up and running and that user experience is valid and those sorts of things. So this is the sort of system that we've had to build in to Office 365 itself. You know, and it's kind of it's a foundational change. You're not saying that debugging is more important when it comes to system monitoring. You're saying that the service experience is the high order bit. Service experience is what you want to make sure is what everyone sees every day and those sorts of things. If you want to find more about this, you know, a lot of these learnings that we had from Office 365, we actually put into the Exchange Server 2013. So you can see kind of behind the scenes of how we do Exchange high availability and site resilience. And our recommended guidance now for as you build Exchange 2013 is covered in OUCB 314 as well. So please check that session out. So in the case of SharePoint, you know, how do we make sure that we have a reliable system there as well? And now, raise your hands if you take backups of your SharePoint server. Anyone? A couple people? No. And we do too. We take a lot of backups, and let's just kind of show you the sort of how we do those backups and how they happen and progress through the system. So have a user here. A user will save a SharePoint document, a Word document into SharePoint. We'll save it onto a disk. We set up that disk. There's one copy. The failure scope, there's no failure scope. If something goes wrong with that save, you would lose the file. So it's a pretty bad architecture to go with. So in our case, we put it across RAID 10. That gives us 2 copies of that particular file. So that means that protects us from an entire disk failing inside of that system as well. Of course, there we synchronize that content across multiple racks inside the data center. And then we use asynchronous log shipping to ship out to our recovery data center that you may recall from a previous slide. So that gives us 6 copy counts. That means our failure domain is now an entire, is above a data center. So we can lose an entire data center and still run this environment and still have your data safe. Then we run scheduled backups across this experience. We asynchronously replicate those backups across data centers as well in that kind of environment. So there's over 10 copies of a particular document that you save into SharePoint Online spread across this sort of infrastructure, spread across at least 2 locations, and spread across multiple disks throughout that environment as well. So what happens if you do want to recover a document? You have a number of choices. For us, if we lose something like a data center or they have massive corruption on the stamp level, we can do point-in-time restores on that particular content. As an admin, essentially what you can do is you can go into your site and look at the site collection of recycle bin, and you can recover those files as well. A point-in-time restore is not limited to your tenant. It's something that we've backed up in the entire service. So we don't do point-in-time restores for your particular tenant. But you can do essentially point-in-time restores of content from your recycle bin in that experience. The user can even do restores from their own recycle bin. The site collection admin can restore from their recycle bin. And if something goes wrong in that save, that initial save of saving something into the data center, like you lose connectivity, network cable drops out or something like that, Office keeps a client-side cache of that document as well. So if something does go wrong in that save, you're still protected, and Office will try and asynchronously save that document up into Office 365 or even up into SharePoint on premises when network connectivity returns. So it's a really resilient system that we have here for saving and storing documents in the case of SharePoint as well. Let's talk about efficiency. So inside a data center, the key thing that we think about oftentimes is the IT load. How many servers do you have? How are those servers running? Are they as efficient as possible? But really the magic of data centers, the magic of running servers at this massive scale of 60,000, 100,000, 150,000 servers isn't so much the servers. I mean, it's really, when you talk to our data center engineers, they're generally either electrical engineers or mechanical engineers, not necessarily software engineers or IT engineers or anything like that, because the problems that they're trying to solve are really around mechanical and electrical systems. For the IT load, for instance, is powered by electricity. There's UPS systems, there's transformers, there's generators, and there's the power supply directly. And of course, having all that electricity and having all that IT load generates an extraordinary amount of heat. And so all of the mechanical systems are all around how you move that heat out of the IT load to somewhere else. And so we have the computer room air conditioning and chillers, condensers, cooling towers, and essentially the water supply that they all connect to. So this, when you get past the servers themselves, this is a real magic of where the efficiency comes out of in a major data center. To give you an example of what that looks like, a typical enterprise data center runs at a PUE, which is a power usage effectiveness, about 2. What that means is for every 1 watt that data center consumes in IT load, 2 watts have to go into that system and just get wasted by electrical leakage, by cooling the systems and those sorts of things. In a cloud data center, generally you'll operate at around 1.2 PUE, about much more efficient than what you can do in just a server room in your office. And really it's because cloud data center is built for machines. It's not built for people. Whereas oftentimes we're victims of trying to retrofit a building designed for humans, maybe 50 years ago, try and putting in a raised floor. I've seen situations where the data center has been on the 3rd floor and they haven't been able to put any more weight into the data center without collapsing the roof. And so you have all these things that we kind of worry about to try and retrofit buildings designed for people so they can just run machines, whereas these cloud data centers are starting from the ground up to be data centers themselves. And we've been at this for a while. It's not something new at Microsoft. We started with your traditional sort of co-location style data center, which is just really a big enterprise data center. You're just renting the space from someone else. You don't really care about the servers themselves. You just run it in a kind of a co-located facility. But then as we evolved past that, we're looking to really reduce the amount of resources we had to use to run these systems to get much more efficient about it. We started to move to a more dense model. We started, rather to install a server at a time, we would wheel in a rack at a time and install a pre-configured rack. We'd buy from our vendors a fully provisioned rack that already had all the machines set up in them and just kind of bolted it in. It's much more efficient to set up that way. It's much quicker to scale rather than having to use your scissor lift to push in every single unit server and those sorts of things into the rack. Fast forward past that, well, how do we get past racks? We started to ship in containers of racks at a time. These things you see there in the Generation 3 data centers, and our Chicago data center has a facility like this, which is essentially ISO shipping containers full of about 2,500 individual servers brought in on a flatbed truck, hooked up and set up in this particular pattern there as well. It was great for containerized computing. It really gave us some economies of scale. As you get to those sorts of models, you actually get less reliability per server. You're kind of operating at 2.5, 3 nines in that sort of environment, whereas in a kind of a rack-based system, you generally get 5 nines out of a system like that and those sorts of things. So it was a change of how we had to start building the software to take account of hardware being unreliable. But it worked really well for a lot of systems like Xbox and Bing that had to scale really fast for these sorts of environments and had really needed to be very, very cost efficient in those sorts of environments as well. The challenge with using an ISO shipping container to ship servers in is it doesn't really have the right thermodynamic profile to run 2,500 servers in it. Great for shipping couches, maybe even cans of beer or something like that. but not so great for servers. And so we moved past that into our Generation 4 data centers, which are really modular designed, same sort of principles, but really designed to have the entire data center built into the container itself. You can see in the picture there, the Generation 3 data center, it's still in a controlled facility. We're still doing cooling and air control in that system. Whereas our Generation 4 data centers are really designed to live outside. They're designed to just be sheds. There's no building at all, essentially, around these sorts of things. To give you an example of that, Quincy Data Center, this is our research and development data center that Microsoft uses a lot, and Microsoft Research do a lot of their planning there as well, pioneering this sort of model. And this is kind of an example of it here. I've got some better photos. You can see here, this is what the hardware engineers look like out at the Quincy Data Center. They look a lot like truck drivers and construction workers. Essentially, you can see the racks there. On top, they're bolting in the air handling unit. And what happens is that as air passes through those servers, air gets hot. The air handling unit pulls the air out the top as hot air rises and has vents and fans to control the flow of the air and those sorts of things as well as it passes out. So, it's really built, it lives in a really big shed like that. No walls needed. We do build a roof over the top to try and keep, the harshest elements out of it. But then you can see on the front there an evaporative cooling unit that plugs in the front, and then an air recycling unit that as the air handling unit pumps out the air recycling unit pulls in some of that hot air to keep a consistent temperature moving through those servers as well. So that's essentially a Generation 4 container. That's what a data center looks like these days rather than a really big building. It's fascinating stuff. I remember the first time that I went and saw a data center this size. And it's like if the first time going to like a port or a dock and you see one of the battleships or even a cruise liner and you just the size of the scale of this building you've never seen before in your life, and it kind of blows your mind a little. And that's kind of how I felt when I saw these data centers for the first time. I'm like, oh, so you guys really don't care about individual servers. At the time I was still naming every server with kind of a Teenage Mutant Ninja Turtle name or something like that, or an impressionist painter. How many people have weird and quirky server naming rules? No, just me? Okay. So yeah, now these server numbers essentially have barcodes. That's about as close as they get. Dublin Data Center, sort of a different environment for Quincy. Quincy's out in the plains, so it gets quite hot. Dublin is cold. It's a nice place for data centers that use a lot of heat. It's very efficient, uses outside air, just like the other models, but it doesn't have that same model. Essentially, it's a more up-to-date, co-located or Generation 2 facility in that we run these sorts of pods here. Same sort of philosophy in terms of how they're used here. The air flows out in the cold aisles, or essentially the outside air aisles outside of the data center. The servers pull that air through, and you can see these two sets of racks are kind of sealed and they have a door on them and those sorts of things. And that's to control the airflow. That middle area is actually a lower pressure sort of area, so that as the cold air moves in, pulled through the data center by the pressure difference, and then as it heats, it gets pulled out the top and circulated that way. So we get a lot of those same efficiencies that we get in the containerized computing, just in a more traditional co-located facility in those sorts of environments as well. So let's talk about management of those systems as well. We've shown you how to build a really, really big data center. All you need is $3 billion, and you're off to the races. So let's show you, some of the ways that we control some of that management aspect, those sorts of things as well. Firstly, and this is as good for you as it is for us, is role-based access control. We are big fans of role-based access control. This is the stuff that you should be running with all of your on-premises servers to control the access to those servers. You don't want God admins. You don't want that kind of bastard operator from hell that has all the controls, all the power, and those sorts of things in your environment. That's just a risk. And so we use a lot of role-based access control to control who has access to the service, what they can do, where they have access to. And you can extend this, and you can use this yourselves when you're configuring Office 365 to make sure that an admin, for instance, only has mailbox rights for particular users, particular locations, particular groups, and those sorts of things as well. You can have compliance officers that are only responsible for certain geographical areas or certain teams or something like that as well, all with role-based access control. So a bit of a plug for that technology. And it applies to Office 365 operations as well. Unlike a traditional server, our Exchange server is not joined to the Microsoft corporate network. Right? It's not something, it doesn't have a .microsoft.com address or anything like that. It runs at a separate Office 365 data center network. So for our admins to connect to that sort of network, they essentially use role-based access control. We go one step further with our role-based access control that we give no one permanent permissions on the Office 365 service itself. They request permissions, and we grant those permissions just in time. We take away those permissions once the action has been completed as well. So we have a system that we call Lockbox. An admin requests the permission to make a certain change on a system. The Lockbox system essentially applies that role-based access control to a particular user. Maybe that needs to go through an escalation process so that an incident manager or another senior manager or a review board needs to look at that particular request before it's granted. Those permissions are granted. The least privilege required in that particular system, and that temporary privilege is granted, and they connect to the Office 365 data center network with separate two-factor authentication requirements or multi-factor authentication requirements there to work on the Office 365 system itself. So this is essentially how we get that sort of scale. It's how we meet some of our compliance demands and those sorts of things. And everything is logged. Everything is auditable. And you can even actually audit some of these tasks yourself. So if you go into Exchange Online, you can run a report, an access report, and it will show you not only which of your own admins have had access to which systems, but whether any of this sort of administration has happened as well. It's the same kind of reporting and logging funnel that we're pulling off those reports as well. So for that reporting, we also have, you see some of that in the Office 365 dashboard for your particular tenant, but we also pull in that reporting data into another system so that we can look at and manage multiple tenants. So I want to show you kind of a quick demo here of some of the systems that we use to make sure we can keep managing Office 365 the way that we do as well. So this is an example of the service, the Office 365 Service Pulse tool, we call this. And the data is old, and I'm not showing you all the data here. This is a particular subset of access, and it's very old, so don't get hung up on the architectures or IP addresses you see or anything like that. But essentially, this is the system that we look at for a lot of these systems. You see green boxes, yellow boxes, red boxes. They're all representing different servers there. The green ones are fully operational, accepting traffic. The red ones are being re-imaged or down, and the yellow ones have been re-imaged but are not yet accepting traffic. And you can see here we filter by various views. Here we can have a look at a data center view, look at how different data centers are performing. We can have a look at particular roles that those servers are playing. We may want to look at hub transport roles or mailbox roles or something like that. And we can view into those. We can drill into those particular items themselves, and we kind of bubble up a lot of those stats about every individual server. So that's how we get from managing this massive service to when we do have to apply those sorts of granular things as well. And you can see there, they can try and connect with two-factor authentication, go through that lockbox approach if they need to do any particular things on those particular servers as well. So that's essentially kind of how big the service needs to be. And when you have systems of this size, it's almost hard to visualize what you need to do as well. It's so much easier to manage just a handful of servers. So when you grow to this sort of size, we need to build new tools to help us manage those systems as well. We also need to build new operations models for how we essentially employ people and the role of people to perform those sorts of actions as well. And we've evolved over the years different models of how we can operate Office 365 as good as possible. The first, or the traditional IT approach, is you have the system itself. You have an operations team that manages that, and the operation team escalates to the product team when they have problems. That's kind of the model that you use today when you have on-premises systems, that if there's a big issue, you call our support desk. Support will eventually escalate. And if the issue is severe enough, it'll escalate all the way to the developer that worked on the issue itself. When you have a service IT model, you may tier that out a bit more. You'll have a tier 1 operations team to, have you tried turning it off and on again? Is the blue cable plugged in? To tier 2 operations, all the way up to tier 3 operations and those sorts of things as well. But as we started to look at Office 365, and as we offer 99.9% uptime SLA, that essentially means that we can only be down 43 minutes a month. How long do things take to progress through a tier 1, tier 2, tier 3 system? Sometimes you just feel like yelling through the phone, escalate, escalate, escalate. Like, I know what I'm doing, tier 3, please. So we looked at sort of direct support models where we had 10 to 12 different engineering teams that actually were on call. We took them off working on the next version of the product just to man the calls for a week at a time. A week backup, then a week primary, to manage some of these calls and those sorts of things. And the engineers hated it. They hated it. They hated being woken up at 2 a.m. in the morning to fix these issues. They hated being taken away from working on the new stuff, having to support the old stuff. But a funny thing happened that over about a 6-month period, code started to get a lot better. Systems started to be built with failure in mind so that they could keep running. And they could keep running until 9 o'clock in the next morning. That when failures occurred, they weren't severe customer-impacted failures. They were just service degradations, or they gracefully failed over different systems, and a server had to sit there, turned off, blue-screened until the morning, until someone could come in and have a look at and identify the problem. But it wasn't cause for waking someone up at 2 a.m. So that was a great thing for kind of our engineering team, and all of Microsoft to think about as we transition to this kind of cloud service model rather than an on-premises software model as well. So our latest model is really engineered operations, and that's kind of an extension of that service ops direct support model. Is that rather than have a special tier 1 support org that can kind of identify the problems, because it's hard actually as a tier 1 support guy, it's often the hardest job. You have all these issues and none of the context. Like how do you know which team to escalate to and those sorts of things. So in our engineered operations model, we spend a lot more time automating a lot of those checks so that they're automatically raised, automatically directed, automatically debugged, and as much self-healing as possible so the system can recover, can fail over gracefully. If a machine, in the case of a high availability or managed availability, an Exchange server tries to reboot itself if it detects a problem. If it detects a problem again after the reboot, then it just blue screens itself and just stays down. It's like, sorry, I'm out. That's what you saw those red servers doing. They're out. They're waiting for someone to go and have a look at them. And the model just is, you have enough of those servers and you have your mailbox in enough places that you can afford to have a server fail. You don't care if a server fails. You only care if the service fails. And so that's essentially how we work with software-aided processes there. Then we do start to build out a dedicated operations role as well. A dedicated people that understand this operations model, incident managers, communications managers, and these sorts of people that have enough seniority and understanding to wake the right people up at 2 a.m. in the morning to fix the right issues and those sorts of things as well. Traditionally our model was all around, we call it the kind of the triad or the holy trinity of engineering, where you have the developer, the software development engineer, the tester, the software development engineer and test, and the PM, or the program manager. And the program manager wrote the spec, the dev built the code, and the tester tested the code. But now more and more, I think you'll see us evolve more and more into this dev test ops kind of square, if you like, of roles as the service becomes more and more important, and you need to start building these sorts of systems, automation, monitoring, and testing that makes sure that we're building resiliency by design and we're kind of a resiliency-oriented programming. Okay, so let's talk about building a secure system as well. I pulled this graph a while ago because I think it really illustrates the point that security is very, very, very important in cloud services. It's even more important the bigger the cloud service is. I don't know if anyone remembers this. This was the NASDAQ, is the Standards & Poor's 500 ratings for the stock market. And you can see that massive drop just after lunch in April. And what caused that? It caused that by the Associated Press's Twitter account being hacked. Look at that drop. One hack, one misplaced communication message, and look at the impact of that time as well. So, you have to take, the bigger the system, the bigger the target, the more important the security is. So we spend a lot of time focused on how we build the security infrastructure as well. We have a whole session about this conference as well, Office 365 security. But kind of to give you the high level, to give you the Cliffs Notes version, there's a bunch of security that we're responsible for, whether that's encrypted data, secure network, isolating the customer data, monitoring the physical hardware, monitoring the network, the best practices we have from our security approach, the automated operations we talked about. There's also a role for you to play as well. And you're not outsourcing the responsibility. We're taking a lot of that load from you, but it's still, at the end of the day, it's your data, it's your systems, you're running it for your customers, and if security is something that can get you fired, it's not something you can fully outsource, right? You still need to have a lot of control over it, and that's why we have a lot of IT tasks around compliance, configuring advanced encryption, user access control, antivirus, anti-spam, because that stuff is very important to your business, and that stuff you still need to manage, and you still need to map the appropriate security posture to the risk frameworks of your particular businesses as well. And then, of course, between the stuff that you do and the stuff that we do, that kind of forms a compliance framework as well. And we get our stuff independently verified, things like ISO standards, EU model clauses in the case of Europe, FISMA, FedRAMP, HIPAA, all those sorts of standards as well to verify that this system is running the way we're saying it is. Advanced encryption, I think this is an important point to talk about. In the latest Office 365 release, we started to use BitLocker to encrypt the hardware at rest. We always did encryption in transit. We didn't do encryption at rest. Now we're starting to encrypt those servers themselves, starting with Exchange. This is great. It's something that people have been asking for quite some time. I think one of the things to understand, though, is that it's encryption at rest is really to mitigate a particular risk, and that particular risk is someone stealing a hard drive. If that's a risk that applies to you, then someone stealing a hard drive. So if that's a risk that applies to you, then absolutely you need to take those precautions. But again, in a case of a 100,000 server data center that's 24/7 monitored and those sorts of things, it may not be such a risk. It's still us doing the encryption. We still have the keys. It's not like the hard drive to Exchange is encrypted and no one can get access without asking you. So that's something to bear in mind with BitLocker. A better approach for that is rights management services. Rights management services means you can control the keys. You can issue the keys. You can store data in Office 365 that's fully encrypted to whatever standard you like it to be, and then you can start to manage that. And so we really encourage customers that are concerned about security to implement rights management services as well. We've done a lot of things around rights management services online to make it easier to set up rights management services and integrate that with Office 365. And there are a whole other encryption and access control technologies that we use in Office 365 to make it more secure and to meet the different regulatory frameworks and security classifications that we need to meet as well. Which is a great segue to compliance. When we think about compliance in Office 365, we generally think about this compliance management framework. There are a lot of different standards out there in the world, depending on where you are, the state you're in, the country you're in, the industry you're in, the type of people you employ. You have different standards, different regulations that you need to meet. And so that is a really important thing to do. But one of the things that we don't want to do in Office 365 is try and meet with conflicting standards. One standard may say you need to do this, another standard says that you need to do that. How do you marry them all up together? And so we essentially have kind of a pyramid like this that is basically starts with the business rules, and we try and take a standard or a control framework, and we try to break that standard down into all its component assets. So one particular standard may say that you need to keep logs on admin access controls or something like that. Maybe that's the policy that we pull out of one standard. Turns out a policy like that, if we genericize it, can be shared amongst a number of different standards. So rather than try to re-certify every time for that particular standard, we just certify that policy itself. Then we build off that policy control framework to make sure that that policy is implemented the same way every time through automated operations. And then a set of control frameworks makes up that standard. And essentially what we do, we use ISO 27001 to attest and certify that we are following all of those policies and those control frameworks, and then all the other standards that we abide by essentially pull from that control framework that we've documented through ISO 27001. So you can request these standards, these control frameworks from Microsoft. We're happy to share them with you. Just talk to your Microsoft representative about those sorts of things as well. And they're finally translated into operating procedures and the way that we carry out the service itself. And again, we'll cover this more in the security session, but I just wanted to give you a taste of the sorts of standards and compliance standards that we meet right now. ISO 27001, a data processing agreement. A data processing agreement is something that not only requires us to sign, it also requires you to sign. It's an agreement between Microsoft and your company that you're following this data processing agreement, and that's often a prerequisite for a lot of different compliance standards that you need to meet as well. SSAE 16, SOC 1, Type 1, Type 2, FISMA, HIPAA, FERPA. I just love the name of all these US standards. They kind of rhyme. FISMA, HIPAA, FERPA, BAR. EU model clauses, EU safe harbor, which is essentially saying that when you move data outside a particular region, in this case Europe, that you keep all of the same privacy and data protection policies as if the data resided in Europe. And that's a prerequisite for many companies and organizations doing business in Europe. Okay, so let's change tack a bit now and talk about the continuous evolution of the service and how we kind of keep it up to date, keep it moving forward as well. 2011, we released Office 365. And then in February this year, we released the refreshed Office 365, which we nicely called the new Office 365. That's what a lot of people see. They see that release and they see that release. But the reality is a little bit more cloudy. There are a lot of releases that happened between those two dates. We actually ship very regularly, every month, every quarter, every 2 weeks in some instances. The Yammer team does builds daily when they release software to the service and those sorts of things. So this is just an example of some of the features. And some of these features are pretty big. Some of these were significant code drops. We've kind of re-architected some of these systems about 6 times in that same system. So it's not just kind of service packs or public updates being applied to this service. There's actually a lot of functionality that gets evolved through the service as well. So how do we do that? We need a very rigorous change management approach to do that. Firstly, the majority of changes that we make, we do through code. This is really important. Again, it prevents that configuration shift that I talked about earlier. It's also great because it gives you a great framework to roll back, roll forward. It versions all of the changes that you make as well. It also means that the changes that we're making here eventually will accrue to the on-premises service as well, where applicable. Some people think that Exchange is different on-premises and online. We only build one Exchange. It's important to understand that the code changes that are made in one, there's only one branch of the code for Exchange or SharePoint or Lync or even Office. We don't have different versions of the code. So every hotfix, every update gets applied to that same branch of the code as well. And then the code is at a point in time, it says, yes, this is going to be CU1. This is going to be the public update. This is going to be the service pack and those sorts of things. They're kind of moments in time on like the number line that is kind of versioning of one of these products. The great thing about Office 365 is that you're always at the front of that number line. You never kind of back as far as you are with on-premises software. And the reason is because we have one topology. We understand what that topology is. We can ship it faster. We do a lot more testing and all the different weird and wonderful configurations that you can possibly build on premises before we will release something as a service pack or something like that as well. There are times where things are changes, configuration changes, or non-code changes are made, and they go through multiple series of reviews. We still tend to automate those sorts of changes as well, using things like PowerShell to make sure those changes go through as well. And the people that design the change, and the people that implement the change are two different people, and the implementers have veto power. They understand what else is going on in the service. There might be different things going on, different changes going through at the same time. So it's not just a case that every developer can go in there and ship their own change as long as they get their manager to buy off on it or something like that. Changes are planned, reviewed well before they ship. Often they're scheduled a week or more in advance. That means they have to get it right. It has to go and get verified in the pre-production environments before it eventually makes its way into the production environments as well. But for things that have to happen faster, they fall under our incident protocol as well, which we'll talk about more in the service management presentation later this week. But again, that is even more rigor around the supervision before it's deployed. The on-call team, everyone that's on call is aware that there's an incident going on, that there's a change that's being pushed out to try and to restore the reliability of the service. So they fall under a different process as well, with different post-incident reviews and those sorts of things as well. So how do we do that? We have a dev, a test, and a production environment. The reality is we have multiple dev, test, and production environments that a build needs to pass before it makes it out. So we really treat production as the most sacred experience we have. We don't want to deploy code directly into production without testing it. Reliability is the high order bit. We're pushing out a lot of those changes, but not at the expense of reliability of the service. So essentially what happens is that a developer will have some sort of ad hoc environment they're using to build and just test internally their system. They're ready to sign off on a particular change or update. They'll do some pre-check-in validation. Then there'll be post-code check-in validation that will go on in that service to make sure it's okay. And after that, essentially it makes its way into the official daily build and the official test environment for that day's code. So then that day's code is tested, and then it slowly trickles out through, essentially, you can think of them as rings of production, concentric rings of production, like dropping a stone in a puddle. That's essentially how we slowly roll out those features. Generally, it takes about 2 weeks for a feature to fully roll out, depending on the feature. Some features will get pushed out faster. Some features will get pushed out slower if it's a bigger change and it has the potential to impact people more. So first one it hits is our service dog food experience, and that is essentially that is the Microsoft IT environment. That's our experience. It's probably the least reliable of all the Office 365 experiences. Is the one that runs Microsoft's own mail systems, Microsoft's own SharePoint sites, and those sorts of things. As it goes through that, as it passes all those checks, it makes its way into what we call a slice in production or SIP environment. This slice in production is a subset of tenants being upgraded, and so we kind of test the waters there. We make sure nothing goes wrong in that particular environment for those particular tenants, then slowly replicate out that change to other slices in production until all of production is updated with a feature as well. So that's kind of the long-winded way of how a feature gets rolled out in the service itself. This poses some challenges, to be honest, in some of the things that we do. We can tell you that a feature is coming. Where is the feature for your particular experience? It could be somewhere in this pipeline. If a feature has said, no, it's not stable, we'll abandon that particular build. So it could get all the way to the service dog food. There are issues found in the service dog food. That whole build is abandoned, goes back to stage one, then replicates out a while. So that's why you see some changes take quite some time to replicate out. The Office web apps rollout back in October, I think took about 6 weeks for us to replicate it out to each environment, each tenant, all around the world before everyone had that feature. So, the question comes to our PR department is like, when do they declare the feature is launched? And it's like, well, it started launching, it's not finished launching. So oftentimes now you hear us make more noise about when the feature is finished deploying rather than when the feature has started deploying. And so that is something that I'm sure we'll get better and better at. But again, it's not something that we want to rush at the expense of reliability to the service itself. Okay, so let's talk about some of the benefits to IT now as we wrap up the session as well. Anyone recognize these sorts of titles? This is ITIL, for those that haven't seen it. I like to think of ITIL as kind of two areas. It's the stuff you do to run and the stuff you do to kind of grow and transform. And so the run stuff, is like service desk, keeping the lights on, the maintenance of the systems and all that sort of stuff. And then the grow and transform stuff is the new systems, the change, the meeting business requirements, and those sorts of things as well. I also like to think the run stuff is the stuff that you have to do, and the grow and transform stuff is the stuff you want to do as an IT guy. And so for you guys, who would say they have a 50-50 split in their job between running, keeping the lights on, and doing new things in their job? Anyone? A couple of people? Who's more like 75% keeping the lights on, 25% changing it? Who does nothing but keep the lights on and they were no one? Well, that guy's still at work. He kind of doesn't have any time to get to TechEd. Typical IT budgeting looks something along those lines that 63% of time is spent on the run side, of money is spent in the run, and 37% is spent in the grow and transform. Keeping the lights on is always a priority, even for Office 365. Reliability is the high order bit. That's our priority too. You're often maintaining commodity capabilities. Everyone loves to think that their particular requirement around mail is so much different from everyone else's. The reality is it's mail. It's probably a commodity service because that's the only way that mail can communicate across those different companies. And so it requires you to be kind of a generalist, to be kind of broad and shallow in your skills. You need to know how to get the SharePoint server back up and running, how to get the Windows server back up and running, how to get the AD server back up and running, et cetera, et cetera. And it takes away the time that you can do kind of new stuff, cool stuff, and interesting stuff from your job as well. So, the view of how we think that IT should evolve in Office 365 is how can we take on some of that load of that run from you? Like, how do we lighten the load when it comes to running so you can spend more of your time doing things that are truly different for your particular business or organization? Like, what are the real requirements that your organization has? It's not necessarily around mail. It's more about better communication, or it's about adopting a new framework, or transforming the business, or meeting a change in the way that people are expecting to working. So it's really changing from maintain to evolve the business there. And that's essentially how we expect to see you change your businesses as you adopt things like Office 365 and as we give you a cheaper way to run these sorts of services as well. And it increases ROI if you need that stuff for your boss when you get back to the office. But really, how Office 365 helps you get there, it's not outsourcing. I kind of hate the term outsourcing, but it is a way for you to outsource those commodity tasks, right? Those commodity tasks like worrying about hard drives, or worrying about network, or worrying about the state of the data center, or is the air conditioner repaired and running in the server room, and all those sorts of things that just take up time away from the things that you should be doing, the interesting stuff. It's much cheaper to run at scale. There's huge economies of scale that we can run at here as well. You get the latest technologies. We're always updating the service. The service moves faster than the servers. And so you get more capabilities faster when you're using Office 365. And there's no build time. If you're on Office 365 and all of a sudden you want to try SharePoint, you don't have to do some impact studies. You don't need to do sizing or anything like that. You just create a new site and you're up and running immediately. So you can add some of these new workloads that maybe you never got the time to do because you were spending all your time running just the one focus instead. And so, back to kind of our ITIL framework or our operations framework here, what we're really saying is that you're spending more time on the service strategy and the service improvement and the service design stuff. There are still things that you have to do in those other areas, but we're trying to lighten the load here with Office 365 on those service ops, those service transition roles, so you can focus on really changing the business and driving the change of the technology adoption in your business as well. And it helps you focus back on your users rather than your servers. And that's a big shift. We've been focusing on our servers for quite some time. The entire presentation here today was me talking about how the servers work. But it really, the idea here is to focus on the users. Like, help them drive the new technology, help them adopt, and help them change the way they're using technology as well. You stop being someone that manages technology for the business to someone that uses technology to help the business grow. And I think that is the future of the IT department and the IT role. And I'm very excited to be an IT pro in this kind of new economy and how it will work as well. So with that, that's a very quick lap around Office 365 and how we support enterprise grade services through scalability, reliability, and efficiency. I have some prizes at the end if anyone wants to wait. It helps you evolve your business as well. Outsource those commodity tasks, reduce the platform costs, and those sorts of things as well. And that's great when you're on Office 365, but to get there, we have a recommended methodology called Fast Track. It's really about how you move from pilot, you seamlessly move from pilot environments into production environments, and then you can take and extend additional capabilities after the track as well. We have a website here. We're down at the booth all day, every day, so we can talk more about you there on the Office booth. We're giving away T-shirts like candy down there as well. And I'll put up this list of other sessions that I really think that you should attend if you're interested in Office 365. So with that, thank you very much for your time. I hope that's been an insightful presentation for you. And if anyone wants to ask any questions at the end, feel free to come up the front. I will pay T-shirts for great questions, so feel free to join me. Thank you again.